Hi students, this is AJ sir. Let's study 10th standard ICSE math chapter 5b and 5c, quadratic equations by factorization method. Chapter 5, quadratic equations. It's an equation with one variable in which the highest power is 2. So that's square, 2x square, x square, etc. Exercise 5a is cancelled. Now if you write the quadratic equation in the standard form, which is ax squared plus bx plus c is equal to 0, and by comparing it with this format we can get the values of a, b and c, then the discriminant is b squared minus 4ac. Even without solving the quadratic equation, if we can first find the value of b squared minus 4ac, then we can comment about the nature of the roots. If the value is exactly 0, then the roots are real and equal. That means the two answers are the same. So we have a distinct and a unique solution, a single solution. If the value of b squared minus 4ac is greater than 0, any positive number, then the roots, that means the solutions, the values of x in the end after solving, they are real and unequal. So we'll get two different answers. And real numbers include not only the rational numbers but even irrational numbers like square root of 2 or square root of 13. However, if the value of b squared minus 4ac is less than 0, then the roots are imaginary, that is, they are not real. For example, there will be a square root of a negative number involved. So we can't solve such sums ahead at school level. Exercise 5b, question 1, Roman number 2. Without solving, we have to comment about the nature of the roots. So first of all, if we compare this equation with the standard form, we can get the values of a, b and c. A is 6, minus 13 is b, and 4 is c. Then we find the value of b squared minus 4ac, which is 73. It's greater than 0. That means the roots are real and unequal. Similarly, Roman number 4, sum. A here is 1. If you don't see any coefficient, then that means it's 1. B is 2 root 3 and c is minus 9. Don't forget to include the negative sign here as well. Then when you find b squared minus 4ac, you solve it like this. 2 root 3 square. How do we do that? Well, first do 2 square, which is 4, into root 3 square is 3. Root 3 into root 3 is 3. So that's 4 into 3, 12. So you can show this step, or you can do it directly like this. And we get the answer as 48. It's greater than 0, so the roots are real and unequal. That means you have two different answers of x. Now Roman number 6, same way we solve, and we get the value of the discriminant as minus 8, which is less than 0. It's a negative number. That means the roots are not real. That means we cannot solve this quadratic equation ahead either by factorization method or by the formula method. This is the formula we will use to solve. As you can see, the discriminant is under a root sign. That means if this value is negative, then the answer becomes an imaginary number. That's why we can't solve it at school level. But if this is positive, that means x will have two values, plus and minus is there. So two different values of x which are real numbers. And if b squared minus 4ac is 0, then this whole term disappears. And so x will have a single value, which is minus b upon 2a. Question number 2.1. Mark it as IMP. Find the value of p if the following quadratic equations have equal roots. Well, if the roots are equal, that means if there is only one value of x as a solution to this equation, that means the value of b square minus 4ac will be equal to 0. So we first of all compare this and with the standard equation and get the values of a, b and c. Notice how b is minus p minus 2. When we substitute the values in the discriminant formula, we have to make sure that we take care of this negative sign outside. The square absorbs this negative sign. You know, the square of any negative number is a positive number. And then we can solve this further. Now, since the roots are equal, it means that the value of b square minus 4ac is 0. That means b minus 2 the whole square minus 16 is also equal to 0. Now we solve this further. There are many ways to do that. One is open the brackets and use the formula a minus b the whole squared, which I have done. Another method would be that minus 16 goes to the left hand side and becomes plus 16. And when the square goes to the left hand side, it becomes square root. Square root of 16 is plus or minus 4. So that's the answer of p, plus or minus 4. Notice that in algebra, whenever you take a square root, you have to mention plus and minus both. Here I've converted into a quadratic equation. So how do we solve this further? We do something called splitting the middle term. Well, the middle number is minus 4 and the last number is minus 12 and the first number is 1. So first we take a product of the first number and the last number, which is minus 12. So I'm just going to write 12 here. And we list all the possible combinations, that is the factors of 12. 1, 12, 2 into 6, 3 into 4. That's it. Again, it will be 4 into 3, which is the same thing. I have to find a combination such that the addition is 4. Addition or subtraction. So this seems to be the right option, 2 and 6. What if I take plus 6 and minus 6 and plus 2? Isn't that minus 4 when you add them? Or you say 2 minus 6 is minus 4. The signs matter, so be careful about that. What if I multiply them? 2 into minus 6 is minus 12. Even that matches. So you see the combination should match this as well as this, the number as well as the sign. So I split this into minus 6 and plus 2p. If you notice, minus 6p plus 2p is nothing but minus 4p. So that's a valid change in the equation. I'm not changing any values here. So we got 4 terms here. The trinomial has been converted into an equation with 4 terms. Now pair it, the first 2 terms together and the second 2 terms together. If you would have taken 2p earlier and minus 6p later, even that is fine. That will work. Now here, what is common? P square minus 6p. What is common? P is common. And what is left that we put in a bracket? P is left here, minus 6 is left here. Plus 2 is common, P minus 6. Always this bracket and this bracket will be exactly same. And don't forget to write is equal to 0. Now, the brackets are common, so take it out common, write it once, and whatever is left over, put it in another bracket. So P plus 2 is equal to 0. Now when the product of 2 brackets is equal to 0, that means either this bracket is equal to 0 or this one is equal to 0. If P minus 6 is equal to 0, then shifting minus 6 we get P is equal to 6, so that is one answer for P. And if P plus 2 is equal to 0, then on shifting 2 we get P is equal to minus 2. So if you want to show these steps you can, otherwise you can mentally do that calculation and get the final answer. Note that these are not the roots of the equation or the solution of the equations, these are values of P, whereas the roots are nothing but the values of x, the main variable in the equation. Now question 3. Again, the equation is given and they have equal roots, so find the value of n. This is exactly similar to the previous sum. On comparing, we get the values of a, b and c. Notice how c is n minus 5. Now b square minus 4ac is 0 because the roots are equal. This needs to be mentioned. Substitute the values of a, b and c and solve. The negative sign goes away here. Here be careful with the signs. First of all, this becomes 12 and opening the brackets, distributive multiplication. Now there is a minus sign outside the bracket. So when you open the brackets, this sign will change to plus. Don't forget to do that. And now the like terms together, I want n alone. 12 goes down, cut, and the final answer is 17. Cancel the fifth question. And now in the sixth, 5c question, 1, 2, 3, 4 are cancelled. Let's do the sixth question. We will use the factorization method. The formula method is for the D exercise. So here I could have taken x to the LHS and taken LCM, but it will be easier for me to just shift x up and open the brackets. So x into 1 is x, x into x is x squared. Write it in the standard form of quadratic equations. This is the standard form. Now I have 1 in the middle and 6 in the end and 1 in the beginning. So 1 into 6 is 6. How do I split 6? 5 and 1 won't work. 6 and 1 won't work. How about 3 and 2? That will work. So 3x minus 2x is positive 1x, correct? And 3 into minus 2 is 6. So that's how we split this. And now what is common here? X is common here. And remember, when nothing is common, just take 1 as common. Here what is common? Minus 2 is common. So what is left? X plus 3 is left. Notice how, since the minus was taken out common, this sign was changed. Of course, the brackets are the same, so take it out common. And the leftover in another bracket. So x is either 3 or x is equal to 2. These are the roots or the solutions of the equation. Next, the eighth question. Mark that as IMP. So first we take the LCM. I want the denominators to be same here. So into x. So that becomes x squared plus 1. And since the denominators are equal, bring them together. Is equal to 5 upon 2. Then you cross multiply it. 2 goes up and distributive multiplication gives us this. X goes up and this is 5x. Now rewrite it in the usual format of a quadratic equation, the standard form. Now we have to split the middle term. First of all, 2 into 2 is 4. So the combination will be 4 and 1, because minus 4 and minus 1 will give me minus 5. And minus 4 into minus 1 will give me plus 4, which is the product. So it matches. The signs also match. Now, between these two terms, what is common? 2x. So what is left? X minus 2. Minus, nothing is common. So write minus 1. What is left is x minus 2. Again, the sign changed here. The brackets are same. So take it out common. And the remaining in another bracket is equal to 0. So x is equal to 2, or 2x minus 1 is equal to 0. That means if you shift minus 1, it becomes 2x is equal to 1. 2 goes down, so x is equal to half. So these are the two roots or solutions of the quadratic equation, which would satisfy the equation. Now we could have written this step directly out here. These two steps are not necessary. If you can mentally calculate the value of x from this, then you will save time. Next, question 10. This is the equation given. So first things first, we have to open the brackets and rearrange the terms to get it in this form. Notice how plus c, the constant term, is missing here. That's fine. That means we don't have to split the middle term. we can simply take x as common. So either this is 0 or this bracket is 0. And if the bracket is 0, then x value is 3 upon 2, which can be written directly. Next, the 11th sum, 4 brackets. So we have no choice, we'll have to open all the brackets. So we do distributive multiplication. X into the whole bracket plus 1 into the whole bracket, and here x into the whole bracket plus 7 into the whole bracket. Again distributive multiplication, and we get this. Get all the like terms together, get everything on the LHS, and we reach this stage. Now again, no need to use any formula. We can just shift minus 13 to the RHS, and squared becomes a square root. And when we write the square root, we have to mention the plus and minus sign. So this is the final answer, plus and minus root 13. Next, mark the 14th sum as IMP. Here, if you notice, this bracket and this bracket is the same, and there's a square out here. So we'll assume that to be, let's say, y. So that becomes 4y squared minus y minus 14 is equal to 0. That's a quadratic equation in the standard form. Now it will be easier to solve rather than opening the brackets with a square formula. Splitting the middle term is 1, by the way, minus 1. And 4 into 14 is 56. So we have to make a list of all the factors. 1 into 56, 2 into 28, 4 into 14, 7 into 8. That's it. Now which combination gives me the middle term 1? I guess this one, because 7 in 8, difference would be 1. But the signs, well, it's minus 1 here. So the bigger number will have negative sign and the smaller number will have the positive sign. So that 7 minus 8 is minus 1, and the product is minus 56, which is 4 into minus 14. So everything works out well. Split the middle term. In the first two terms, 4y is common, and here plus 7 is common. Two brackets equal to 0. So you get two values of y, but the sum doesn't get over here. Don't forget to re-substitute the value of y as x, and then solve further. This is just normal algebra, and get the two values of x. So notice that x usually has two values, perhaps because the discriminant b square minus 4ac is greater than 0 in all these cases. If the b square minus 4ac value would have been 0 for any equation, we would have got a single answer for x, because both the roots would be equal. Next, the 16th sum. It's the usual splitting the middle term method again. 2 into 10 is 20. So minus 9 has to be split to give me 20. So the combination is minus 4 and minus 5. So that minus 4 minus 5 is minus 9. But their product is positive 20. Then take out common the two brackets and get two values of x. But in Roman number 1, they have mentioned that x belongs to natural numbers. So this would be rejected as a solution. So the only answer is x is equal to 2. But in Roman number 2, it is mentioned that x belongs to rational numbers, which includes fractions as well. So both the answers would be accepted for Roman number 2. Next, mark the 18th sum as IMP. So here we have to take the LCM first of all on the LHS. So here into x plus 3 into x plus 3, and here into x plus 2 into x plus 2. This way the denominators become same, so we can bring the fractions together, bring the numerators together. The RHS just copy. Now we shall open these brackets, and even in the denominator start doing distributive multiplication. So finally we get this. Now we can cross multiply. So this into the denominator, and this into the denominator. Again open the brackets, get all the like terms together, and write the final quadratic equation in the standard form. and do splitting the middle term. 2 into 14 is minus 28. So 3 has to be split into two numbers such that their product gives me minus 28. So that 7 minus 4 is 3 and their product is minus 28. So this is the perfect pair. You know how to get it by writing the factors in the rough work column, or you can do it mentally. Then take out common, you get two brackets equal to 0, and that's how you get two values of x. Now the 20th sum. Notice how we have plus and minus, but even the denominators are different. So the first thing we do is LCM. So here it becomes x plus 1 and x plus 1 up and down, and here denominator x minus 1 and numerator also x minus 1 up and down, so that we can get the numerators together. So this is the first bracket and this is the second bracket, equal to 7 upon 8. On solving further, we get this. Notice the numerators now. X plus 2 into x minus 2, that's a plus b, a minus b formula, that is a square minus b square. That applies for the denominator as well. Notice there is multiplication out here, so no need to do LCM here. LCM is required only if there is addition or subtraction of two fractions. Now you can cross multiply, and on solving further we get this. No splitting of middle term required here. We get the answer as plus or minus 5. Next, 21.2. In this question we have to find the quadratic equation and the solutions are given. 2 and minus 2 and 3. So x is minus 2 or x is 3. So if I shift it to the LHS, this becomes x plus 2 is equal to 0, and similarly this becomes x minus 3 is equal to 0. So if this is 0 and this is 0, then their products will definitely be 0. Now open the brackets, distributive multiplication, and whatever answer you get is the required quadratic equation. This is the final answer. Next, 22.2. Solve the equation, if possible, for real values of x. If possible, that means that we will have to first check if we can get a real answer or not. That means we will have to first find the value of the discriminant, which comes out to be actually less than 0. No need to solve it further. It's visible that this will be a negative answer. So we can't solve it further. So just write roots aren't real. If it was greater than or equal to 0, then we would have solved it by splitting the middle term. Next, the 24th sum. Find the value of x if a plus 7 is equal to 0 and b plus 10 is equal to 0. Well, that means a is equal to minus 7 and b is equal to minus 10. We shall substitute these values in the given quadratic equation and we'll solve to get the standard form. Then we will do splitting the middle term. You can see that 12 into 10 is 120. So out of all the combinations of 120, you will reach 15 and minus 8. Now you should try it on your own. Don't copy the combinations from here, because you need practice in thinking in this way. Then you take out the common terms, get two brackets, and then you can directly write the answers of x. Now the 26th sum. Without solving the quadratic equation, find whether this is a solution of this equation or not. That means, is it a root or not? Well, if this is a root or a solution of this equation, it would satisfy the equation. That means if I substitute the value of x in the LHS and solve, I should get the RHS, which is 0. So that's the way we will solve this. So substitute it in the LHS. Please don't write equal to 0 in the beginning itself. We have to solve it and then check if it is truly 0. So this is normal algebra now. Take out the LCM. So I did into 3 into 3, so that all the numerators are together, and indeed it is equal to 0, which is equal to RHS. That means it satisfies the equation, and so it is indeed a solution. Next, the 28th sum. Here it is given that it's a solution, and we have to find the value of m. Well, if x is equal to 23 is a solution of the quadratic equation, that means it will satisfy the equation. So copy the quadratic equation. Yes, we can write is equal to 0 because it is mentioned that it is a solution. We are not checking that it is a solution. On substituting, now the only unknown variable left would be m, because everywhere else we have substituted as 2 upon 3 in place of x. Now remove the LCM, cross multiply, and get the answer of m as -6. Next, the 30th sum, mark it as IMP. Again, a quadratic equation is given, one of the roots is given. We have to find the value of m, and then we have to find the other root. That means we have to solve the quadratic equation. So first, since it's mentioned that x is a root, that means it will satisfy the equation. So we can substitute the value of x here and here, solve it, and get the value of m. So now the equation becomes this in the standard form. We have to solve it further. So let's split the middle term. Notice that -3 into -2 is +6, and -3 minus 2 is -5. We get two brackets, we get two values of x. Highlight this answer because x is equal to 3 was already mentioned, and they wanted us to find the second equation, which is second solution, which is this. Next question, 32. They've asked us to solve. There are no numbers, but the method remains same. First of all, we take the LCM here, into x into x into a and into a, so that we can get the two fractions together with a common denominator. Denominators get cancelled. That's why they had mentioned a and x are not equal to 0, otherwise cancellation would not be possible. And here I'm going to shift this to the RHS because I would like to have my x alone. This is a replica of this, so I'll write it as a plus b the whole squared. Square becomes square root, and plus or minus sign has to be mentioned as well. And finally, the 33rd sum, mark it as IMP. You have to solve this. Pretty easy. Basic algebra. First of all, upon 1. So into x, take the LCM out here. And this shifts to the RHS. Notice that we can bring them together. There's a multiplication sign. No LCM is required here. X can be shifted to the RHS on top. Open the brackets here, distributive multiplication, get the like terms together, we reach this equation. But I see that it can be reduced further by dividing the whole equation by 2. So whenever it's possible to simplify the equation, do that so that you deal with smaller numbers. So dividing by 2, I get this. Now I need a combination such that it's -40 and 6,000. Yes, you'll have to write the factors of 6,000, but not all the factors. You will have to use your wisdom to find out the possible ranges. So it's -160 will give you -40, and the product will give you -6,000. So to save your time, you need to practice a lot so that you can get the combinations very quickly. Then solving further, we get the two values of x. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.